Fleet of foot. Literally, he had wings on his shoes, and a rapid traveler. To anyone who's seen Mercury in the sky, this affiliation with the swift god is no surprise. Mercury, the planet, moves pretty quickly, visibly changing its position relative to the background stars, even after a single night. Despite its speed, the planet never gets very far from the sun. At best, it can reach a separation of about 28 degrees. That's about 3 times the apparent size of your fist held at arm's length. In 1639, the Italian astronomer Giovanni Suppi used a telescope to observe Mercury, and he discovered
do not need to be saluting Hitler.
cycle of phases over time, just like the moon.
I'm doing Armstrong right now.
The only way that can happen is if Mercury orbits the sun and not the Earth.
Yo, Armstrong is actually so hot. What? The hairline is not it though.
All the time. And of course, that's the way things really are.
He's buff as hell.
Mercury is the innermost of the planets in the solar system. It orbits the sun.
Played college ball, you know.
About 58 million kilometers.
At some cushy Ivy League school. Try University of Texas.
See it stray far from the sun. From our viewpoint, its smaller orbit keeps it huddled closer to our star. That's why we see it move so rapidly too.
I'm fighting
it's closer
Excelsis
to the
right
sun,
now.
so the gravity it feels from the sun is stronger, and therefore its orbital velocity is faster than Earth's.
He carefully played college ball.
Once every 88 days, and that's also why we see
Played college ball, you know.
When it's between us and the sun, we're looking at its dark side.
Cooking the butterball
On the other side of the sun, we're looking at its fully illuminated half. In between,
fret
it
over
goes through
every
the
egg.
same phases as the moon. Crescent, half full, gibbous, and so on. Not that this is such an easy observation to make. Because it never gets far from the sun, it's always low to the horizon after sunset or before sunrise. When we observe it, we're looking through all of the muck and turbulence in our air, so it's usually pretty fuzzy. Making matters worse, it's a DP planet, only about 4,900 kilometers in diameter, about a third the Earth's width. One upside to all this is that because it's close to the sun, it's illuminated fiercely and can be pretty bright even near the horizon. If you ever get a chance to see it, you really should. It's pretty cool. Mercury's orbit is weird. It has the most elliptical orbit of any planet, ranging from 46 to nearly 70 million kilometers from the sun. When it's closest to the sun, it receives more than twice as much light and heat as when it's furthest. Mercury's too small and difficult to observe to see surface features on it, which for a long time made it impossible to figure out how long its day is. Astronomers assumed that the tides from the sun had locked Mercury's spin so that its day was equal to its year, just like our moon spins once for every time it goes around the Earth. However, in 1965, astronomers used Doppler radar to observe Mercury and directly measure its spin, and they got a surprise.
Not Armstrong telling me to fight like a man while he's in a fucking Metal Gear.
88, but that's a significant number as well. To be more exact, the actual length
He's
of
like, fight
Mercury's
like a man,
year
Jack,
is
while he's in a fucking Metal Gear.
87.97 days, and the actual length of its day is
He's in a Metal Gear,
58.65
going against some
days.
random guy.
If you divide those two
I don't think
numbers,
you
see
can fight
the
less like a
ratio is
man.
almost exactly 2/3. It turns out there's more than one way to tightly
fuck
lock
up,
the rotation of
Armstrong.
a planet to its orbit.
fighting
Remember
like a
earlier
fucking
when I said
pussy.
Mercury's orbit is highly elliptical? The tides from the sun are far stronger on Mercury when it's at perihelion, the closest point in its orbit to the sun, than when it's at aphelion, the farthest point in its orbit. After Mercury first formed, tides from the sun slowed its rotation, just like the Earth's tides on the moon slowed the moon down as well. But at some point, Mercury's spin slowed to where it was 2/3 of its orbital period. So at one perihelion pass, one side of Mercury faces the sun. Then, 88 or so days later, it approaches perihelion again. But it's spun 1.5 times, and this means the exact opposite side of Mercury faces the sun at this closest approach. 88 days later, Mercury is spun 1.5 times again, and the whole thing repeats. It turns out that's a perfectly legitimate, stable configuration, just like the 1-to-1 spin-orbit setup. The way the physics works out, tides like simple multiples. Once the day became 2/3 the period of the year, forced by Mercury's elliptical orbit, the tides stopped slowing it. And things have been that way ever since. Mercury's elliptical orbit, together with the 2-to-3 spin-to-orbit ratio, make for a very, very weird day on Mercury. If you stay in one spot, it takes the sun 2 Mercury years, 176 days, for the sun to go around the sky once. That's because if you're on the side of Mercury facing the sun at one perihelion, the other side will face it 1 year later. It'll only be after the second year ends that you're facing the sun again. But it gets weirder. Mercury's spin is constant. It doesn't speed up or slow down. However, its motion around the sun is faster at perihelion than aphelion. At aphelion, Mercury's spin is a bit faster than its orbital speed, so the sun moves rapidly westward across the sky. But at perihelion, Mercury's motion around the sun actually more than compensates for its spin. So the sun appears to stop in the sky and actually move backwards for a few days. Then, as Mercury pulls away from the sun, its orbital velocity slows down, and the sun starts to move west once again as the planet's rotation dominates. If you're at just the right spot on the planet's surface, This means you could actually watch the sun rise, slow, stop, set again, then rise again. And you think time zones on the Earth are a pain. Mercury's hard to observe from Earth, and much of what we know about it is due to observations from space probes sent there. Mariner 10 made 3 flybys of Mercury in the 1970s and mapped about half the surface. We learned that it had almost no atmosphere and was therefore unsurprisingly covered in craters. In 2011, the Messenger probe entered orbit around Mercury after making a series of close flybys. The pictures it returned were breathtaking and revealed a world that has seen a lot of pummeling over the eons. It's covered in craters, pole to pole, some hundreds of kilometers in diameter. The largest is called Caloris Basin, a whopping huge impact feature 1,600 kilometers across. There are some smoother plains on the planet's surface too, which appear to be older than the cratered regions. These plains are covered in cracks called rubees. These are compression folds, like wrinkles on a fruit rind that's dried out. Apparently, as Mercury's interior cooled after it formed, the planet shrank and the crust cracked as it tried to shrink as well. Several of the craters have extensive ray systems. Like on our moon, these are formed when impacts fling out long plumes of material that then settle down on the surface. One of my favorite things of all about Mercury, craters are named after artists. Musicians, writers, painters, and more. So we have craters like Botticelli, Chekhov, Debussy, Degas, Occhio, Sibelius, Vivaldi, and Zola. There's even one named Tolkien. Dipping below the surface, we can only infer what Mercury's internal structure is like. But the planet's dense, nearly as dense as Earth. We know the surface is rocky, so to be as dense as it is, it must have a large iron core, far larger in proportion to the planet than Earth's. Mercury's core may reach 3/4 of the way to the planet's surface. Why does it have such a high proportion of iron? Mercury may have formed as a larger planet, then got blasted in a huge grazing impact that blew away the lighter materials that had risen to the surface, leaving behind the denser part. Or maybe the heat of the still forming sun vaporized the lighter materials off its surface. Mercury has a measurable magnetic field, which is a bit surprising since it rotates so slowly. Rotation plays a big part in the sun's and Earth's magnetic fields. But that fits with so much of its interior being molten iron. The bigger core may allow for a stronger field despite its slow spin. It doesn't have much of an atmosphere, but there is a trace of one, mostly due to its magnetic field trapping the solar wind and to material flung up from the surface after violent impacts from comets and asteroids. A lot of this material blown off the surface escapes the planet and gets blown away by the solar wind and pressure from sunlight. It forms a long comet-like tail that is tens of millions of kilometers long. This tail is comprised of elements like sodium, calcium, and magnesium, material that's known to be abundant on the surface. Speaking of which, here's a fun fact. Pound for pound, impacts on Mercury are more violent than they are on Earth. Mercury has weaker gravity, so it doesn't pull in impactors as hard as the Earth does. But it orbits the sun far faster than Earth does, so asteroids and comets tend to hit at higher velocity. That makes the explosive energy higher, making craters bigger. And there's one more surprise Mercury has, and it's really surprising. Despite being so close to the sun and having a surface temperature that can reach 430 degrees Celsius, 800 degrees Fahrenheit, astronomers have found water ice on Mercury. It exists in the bottoms of deep craters near Mercury's poles, where sunlight never reaches. These are called cold traps, and temperatures there don't get above minus 170 degrees Celsius. It's not known for sure where the water comes from, but it's likely to be from comets and asteroids that impacted the planet, scattering the water across the surface. Of course, in the harsh heat, that water just goes and goes away, but in those deep craters, it can persist, accumulating over the eons. There may be billions of tons of it there. It's bizarre to think that in one of the hottest places in the solar system, there can be conditions so cold, ice can exist. But one thing we've learned about nature over and over again, it has a lot more imagination than we do. Today you learned that Mercury is the closest planet to the sun. It's airless and dense and is covered with craters. Its rotation is locked to its orbit in a 2-to-3 ratio, and together with its elliptical orbit makes a day on Mercury very long and very weird. And despite being very hot, there's actually water ice in deep craters at its poles. Crash Course Astronomy is produced in association with PBS Digital Studios. Head to their channel to discover more awesome videos. This episode was written by me, Phil Plate. The script was edited by Blake DiPastino, and our consultant is Dr. Michelle Fowler. It was directed by Nicholas Jenkins, edited by Nicole Sweeney, and the graphics team is Thought Cafe.
I didn't learn anything.
Lucky.
Yeah, well, my mom just texted me and was like, "Hey, you wanna go go home? Hey, nerd, you wanna dip?"
Why not?
So I just said, "Yeah." Of course I did. Andrew, you want to leave?
If you're a web designer, here are 4 Wix Studio features you gotta know.
No.
All
right, I just killed Excelsius.
You got this wrong.
Venus was the Roman goddess of love. And honestly, if you've ever seen it after sunset, hanging like a diamond in the twilight, the planet Venus is stunningly beautiful. The only problem?
Very.
Venus
Penis?
is hell.
Penis and Uranus. Alright.
Venus
Slippery
is the
little
second rock from the
bastard.
sun, closer to the sun than Earth.
There he is,
It's the third
my
brightest
sweet
natural object in
baby,
the sky
my
after
glorious
the sun and
king,
moon.
Senator
And it's
Armstrong.
shockingly bright when you see it. In fact, a lot of the time when people
came
see
out of
it,
his
they
little
think it's an
pod.
airplane. Some folks, and
He's a
this is
beautiful
true,
butterfly.
even report it as a UFO.
Nano
Like
machine,
Mercury,
son.
it never gets far from the sun.
Yeah, my
It tries
controller's
to reach
moving.
about 45 degrees away. If you want to see it, the best time to look is after sunset or before sunrise. Through a telescope, Venus can be seen to undergo phases just like the Moon and Mercury do too. When it's on the far side of its orbit from Earth, we see the illuminated face, so it looks full. As it rounds the sun and approaches Earth in its orbit, it gets bigger from our point of view because it's getting closer. But it also wanes, it's gibbous, then half full, then a crescent. When it gets between the sun and Earth, it's as close as it can get to us, about 45 million kilometers away. It's a very thin crescent at that point, but
All right,
close enough
now
to us
Ryan's
that you
gonna
can
get
see the phase easily with
clapped.
just binoculars. Ironically,
Played
even though
college
we
ball,
see
you
only a
know.
small portion
That's
of
a
the
cushy
illuminated
Ivy League
phase,
school.
it appears so big
Try
that it's
University of
actually
Texas
brighter than
instead.
when it's full but far away. The orbit of Venus around the sun is tipped with respect to
Well,
the
he
Earth
did that
by a
first.
little over 3 degrees. So, like the moon is seen from Earth, Venus usually passes above or below the sun in the sky as it laps the Earth and pulls ahead in its orbit. But again, just like with the moon,
Try
sometimes
University
things
of
line up
Texas.
just right, and Venus
Could've gone
passes
pro if I had joined the
directly
Navy.
across the sun's face.
Not one of those
event is
beltway
called a
pansies.
transit. During a solar eclipse, the moon can
I could break the
completely
president
block the
in
sun.
two.
But Venus is much farther
My
away,
bare
so it can only
hands.
block about 1/10% of the sun. We see the planet as an
Don't
inky
fuck
black
with
circle
this,
against the
Senator.
sun's face. Transits were very important centuries ago. Scientists realized that by precisely timing the start and end
going to
of
fuck the
Venus
Senator,
transit
yeah.
and
Honestly,
applying
Armstrong's kinda
geometry,
hot.
they could figure out how far away
I like
Venus
fuck
was
off.
and
You just
use
get
that like a
flashed.
meter stick to measure the size of the entire solar system. Grand expeditions were sent to remote parts of the Earth where the transits were visible, but it turns out Earth's atmosphere blurs the disk of Venus just enough that exact timing of the transit isn't possible. Scientists had to wait until we could use radar and other methods to get the exact distances to planets in the solar system. But transits are still pretty amazing to watch. They're very rare. The way the orbits of Earth and Venus align, they happen in pairs, separated by 8 years, but then don't happen again for over a century. The last pair of Venus transits happened in 2004 and 2012. I was fortunate enough to see both the 2004 and 2012 transits, and they were totally cool. But the next one, December 10th, 2117. If you missed the last two, sorry about that. Venus is
gotta be
actually so
fucking shitting me,
bright
bro.
sometimes that it can be seen in broad daylight. I've done this myself. So here's an obvious question. Why is Venus so bright? Telescopic observations show it to be a nearly featureless white disk, completely covered in a thick cloud layer, reflecting almost all of the sunlight that falls on it. Okay, great, so that's why it's bright. But then why are its clouds so thick? Well, it turns out that Venus might be nice to look at from a distance, but up close, yikes! In some ways, Venus is the planet in the solar system most similar to Earth. It's only a wee bit smaller, 12,100 kilometers across, about 95% the width of Earth, and has 80% the Earth's mass. But if it's a twin of Earth, it's the evil twin. Venus is closer to the
And
sun at a
Ryan
distance
sliding
of
along
about
the floor.
110
I
million
love that.
kilometers, 2/3 the distance of the Earth from the sun. You'd expect it to be warmer. What you might not expect is that its surface temperature is 460 degrees Celsius. That's 860 degrees Fahrenheit. Hot enough to melt lead, and it gets worse. Its air is almost entirely composed of carbon dioxide, and atmospheric pressure on Venus is a crushing 90 times that of Earth's. As if that's not bad
All
enough,
talk.
it rains sulfuric acid too. But it's so hot, the drops evaporate before hitting the ground. Yep, Venus is hell. Why? How did it get so hot? It turns out Venus
What a
is a
load of
victim
bullshit.
of a runaway greenhouse effect. A long time ago, Venus may have
All you
been
care
more
about is
temperate
lining your
and
own
might even
pockets.
have had liquid water oceans. But the sun was
Approval
cooler when it was
rates.
younger, and as it aged, it got hotter. At some point, the thinking goes, the sun warmed
All
Venus
the
enough
rest.
that its oceans started to evaporate. Water vapor is an excellent greenhouse gas, so Venus's heating accelerated.
There's
It
another
got so
maggot
hot
crawling
the
in the
oceans
pile.
boiled away. Any
There we
carbon
go.
dioxide dissolved in the water was released to the atmosphere, heating the planet even further and thickening the atmosphere hugely. It got so hot that the CO2 even got baked out of the rocks, which was like, well, throwing gasoline on a raging fire. The greenhouse effect raged out of control at that point. Venus lacks a magnetic field, so it has no protection from the solar wind blasting past it. Over billions of years, this stripped a lot of the lighter elements from the atmosphere, as well as all of the water. The
their
resulting
own
atmospheric chemistry is pretty screwy compared to Earth.
He said the thing.
Sulfur
He said, "I have a
dioxide is a
dream."
popular molecule there, and clouds form from
said, "I have a
sulfuric
dream."
acid. Those clouds are high off of the surface and very white and reflective. It's pretty incredible to think about. The sun
Changes
warmed,
to suit the
so
wind,
Venus warmed.
not the other way
And then a
around.
cascading series of events led to it being a ridiculously hostile environment
Where the
due
power
to the
and justice
runaway
are back where
greenhouse
they
effect.
belong.
Even though Mercury
Lands
is
of the
closer
people.
to the sun, Venus is way hotter. Given that, the last thing you might expect on Venus is snow. Well, possibly. Observations show that there's something shiny on the mountaintops, and snow fits the bill, but it's not water ice like on Earth. As the thinking goes, at lower elevations, minerals like bismuthinite and galena would be vaporized by the heat. They'd then circulate up into the atmosphere and deposit
Andrew, what
onto
time
the
is it?
surface of mountaintops where it's cooler. If this is
can't check.
correct,
1:31.
then Venus is so bizarre it literally
I'm out
snows
of time.
metal there. There's other weird stuff going on at Venus too. For one thing, it has an incredibly
I'm skipping
slow
this cutscene.
rotation rate. One day on Venus is
I
about
have 9 minutes.
243 Earth days. It rotates so slowly that at its equator, you could jog faster than the planet spins. Its slow spin is probably why it has no magnetic
Why
field,
did that
too,
not
since
parry?
rotation is critical in generating the magnetic fields of objects like the Earth and Sun. Not only that, but the planet spins backwards. This is called retrograde motion, and in a sense it means Venus's
checkpoint.
North Pole
Alright.
got swapped with its South Pole. It flipped over. It's not clear why that happened. A lot of ideas have been proposed, including a giant collision that skidded the planet's spin to a halt. But as of right now, Venus's lazy rotation
Andrew's
is
doing a
still
thing.
not completely
you see
understood.
the
If you could survive it, living on Venus would be really odd. The thick clouds mean it's about as bright as twilight on Earth, despite being closer to the sun. The thick atmosphere also means surface temperature is about the same everywhere on the planet, pole to equator. Due to its backwards rotation, the sun would rise in the west, and due to the slow rotation, its day is actually longer than its year. Calendars on Venus would be a mess, but calendars would probably be the least of your worries if you had to live there. Incidentally, Venus has no moon. Being closer to the sun, it's possible that any moon it may have once had would have been perturbed by the sun's gravity and was eventually tossed out of Venus's grasp. It's also possible it simply never had one to begin with. And here's another fun fact. Venus is the most spherical of all the planets. Because it rotates so slowly, it doesn't bulge out at the equator from centrifugal force like the Earth does. The diameter from pole to pole is almost exactly the same as it is through the equator. We don't have a lot of data about the interior of Venus, though given its similar composition and size to Earth, it's not too crazy to think it has a core, mantle, and crust like we do. But even given the weird atmosphere, the surface of Venus is really different than ours. Venus doesn't have tectonic activity like Earth does. It's thought that water helps drive that, and Venus long ago lost its water to the greenhouse effect. Still, the surface appears to be very young. About 1,000
If I can beat him
impact
before the
craters
bell
have
rings,
been
I'm
found,
just
and
the
they're
best.
evenly distributed around the planet. The majority appear to be in pretty good shape. They haven't been eroded
already got him down to
much,
150.
indicating they aren't terribly old. Not only that, but the erosion we do see seems to be about the same for all these craters, indicating they're all roughly the same age. That's weird. This all points to some sort of catastrophic event that resurfaced the planet roughly 500 million years ago. Any features older than that were wiped out, and then big impacts over time created the craters we see now. But what could repave an entire planet? A big clue can be found by counting volcanoes on Venus. There are 167 bigger than 100 kilometers in
I'm
diameter.
down to 130.
A huge number. These volcanoes could, over time, pump out enough lava to cover the entire surface of Venus. There's also a lot of indirect evidence that volcanic activity is ongoing, now, today. One mountain on Venus, called Idun Mons, is seen to be abnormally warm, for example, indicating it might have magma under its peak. Also, sulfur dioxide levels dropped a lot in the 1980s, which may indicate a big volcanic event happened in the 1970s, blasting out lots of the gas, which then subsided. It's possible, though somewhat
Shit.
speculative, that the entire planet is a supervolcano, A ginormous pressure cooker of barely constrained magma. Every few 100 million years, the whole surface lets go in a colossal eruption covering everything in lava. Yikes! Some volcanic features on Venus are different than on Earth. Without tectonics, slow bubbling leaks of lava from the interior of the planet can continue in one spot for a long time. This creates what are called pancake domes, huge, flat, low domes. Many are dozens of kilometers across, but less than a kilometer high. The lava that formed them was probably really viscous, which is why the domes are flattened and spread out. The searing surface temperature of Venus probably kept the lava hot and helped it spread out more too. Oh, and one final note. Under international agreement, surface features on Venus, mountains, plains, craters, and so on, are all named after women or goddesses of various cultures. This is an homage to the planet itself being named after a goddess, of course, but also, it's just cool. Today you learn that Venus is the same size as Earth, but with a super thick atmosphere. A runaway greenhouse effect makes it the hottest planet in the solar system. It has the slowest rotation of any planet and spins backwards.
I'm at his second,
Tremendous volcanic activity ages ago.
I might actually be able to beat him before the bell rings.
And it still may be active today. Crash Course Astronomy is produced in association with PBS Digital Studios. Head to their channel to discover more awesome videos. This episode was written by me, Phil Plait. The script...
23-slide PowerPoint. In 30 seconds.
Hey folks, I'm Phil Plait, and this is Crash Course Astronomy. You know, I can't think of any object in the sky that's captured our imagination, like Mars. The Red Planet was once thought to be the god of war, and in more modern times has been the setting for a zillion science fiction novels, movies, TV shows, and more. And now that we've gone there, landed there, roved there, it's become far more than a simple background for an alien invasion story. It's become a world, a place, and maybe, one day, a destination.
I can't hear it has to be this way because of this music, man.
Mars is the fourth planet from the Sun, and the outermost of the terrestrial planets. That is, ones that are rocky and similar in size to Earth. It orbits on average a little
Listen
over
to the best song in the
200
entire
million
game, but I
kilometers
can't.
from the Sun. That puts it outside Earth's orbit, and it never gets much closer to us than about 60 million kilometers. It's colder than us too, with an average surface temperature of about 60 below zero Celsius. And it's not a terribly big planet. It's only about half the size of Earth. Still, when it's closest to us in space, it shines brightly in our night sky, a red beacon glowering like an angry eye. No doubt this is why ancient civilizations associated it with war. But it turns out Mars isn't red because it's bloody. It's red because it's rusty. Literally, that red color you see comes from fine-grained dust on the surface, almost like ruddy talcum powder. The dust is rich in iron that's oxidized.
This should be the last little.
The dust coats a lot of the surface, giving it a butterscotch or ochre color.
Okay, yeah.
And also gets blown into the atmosphere. A lot of the surface of Mars is also gray volcanic rock called basalt, and together with other minerals gives Mars its overall reddish look.
There's no way I missed
that. We can get a decent view of Mars from Earth using telescopes. But small features are maddeningly difficult to tease out. The idea of a clement environment on Mars stuck with us, though. At least until the 1960s and 70s when we started sending probes to the planet. They did not see a lovely, habitable world. Instead,
this is the last little bit.
Of a dry, dead, forbidding planet. The surface geography of Mars is weird. There's a huge dichotomy between the northern hemisphere, which is mostly smooth plains, and the southern, which is cratered hilly highlands. Apparently, Mars suffered a tremendous impact from an object hundreds of kilometers across, eons ago.
Okay, I killed him.
Left behind a vast basin near the North Pole.
I killed Armstrong.
Which filled with lava. Topographic maps show the northern hemisphere has much lower elevations than the southern, and can be depressed by several kilometers. Walking from the south to the North Pole is essentially all downhill. Another large feature is the Tharsis Bulge, a huge plateau that's home to the four biggest volcanoes on Mars and the largest volcano in the solar system, Olympus Mons. Mars doesn't have plate tectonics today, but there's evidence it once did. Tharsis was probably over a hot spot, a plume of hotter material rising up through the planet's mantle.
I just killed him. Let's go.
Bulge. And as the plates slowly moved, the plume punched through the crust to create the chain of three smaller, but still huge volcanoes. But the grandest of the surface features on Mars is easily Valles Marineris.
I just killed Armstrong.
When the Mariner 9 probe